arrangements in a circle. So here we're going to focus on looking at how many arrangements are possible if people or objects are placed around a circle. So we're going to focus on if we had 3 people, just to start off with. So let's call them A, B, and C. And how many arrangements of just 3 are possible if we're considering just a straight line? So let's look at all those possibilities. Obviously, we've got A, B, C as a possibility. A, C, B. What about B, A, C? B, C, A? C, A, B? And C, B, A. So they're all out. There's 6 possibilities for arranging all those people in a straight line. And what if we put them all around a table? So let's have a look at all 6 of those. So let's have a look. Let's draw up some tables, some circular tables, and let's arrange them all. So we've got, start with our first one, A, B, C. Our next one is A, C, B. Our next one is B, A, C. Our next one is B, C, A. Our next one is C, A, B. And our next one is C, B, A. Now, the real question is, are all of these different? And the way to determine if they're all different or not is actually just to start with the same person. So let's go around the table in a clockwise direction, starting with person A. So if we start with person A, this one is in fact A, B, C, this arrangement. What about the next one? So we start with person A, go in a clockwise direction, and we get ACB. So again, let's start with person A and go in a clockwise direction. And this one's ACB. Start with person A, clockwise direction. And this one's ABC. Start with person A, clockwise direction. So this one's also ABC. And again, starting with person A in a clockwise direction. And this one's ACB. And hopefully we can see that there's only 2 possible arrangements with these 3 people. They can be seated as ABC or ACB. Because when they're arranged in a circle, it only matters who's on their left and their right for every person or every object. And this leads us to the total number of arrangements in a circle is actually, it's just the number of people or number of objects minus 1 factorial. So in this case, we had 3 people. So it was 3 minus 1 factorial, which is just 2 factorial, and 2 factorial is 2. So how many ways could 7 people be seated around a table? Well, that's just 7 minus 1 factorial, which is 6 factorial, which is 720 ways. But what if there were some kind of restrictions? What if we had 15 students in a class and 3 students wanted to sit next to each other? All around one big table. So if this wanted to happen, we can imagine one big table, and we actually want to treat these 3 students as one student. So that would mean that those 3 students are all going to be treated as one student, So we can do 15 minus 3 to give us 12. Add one of them back, as they're all the 3 students as 1. So this 1 represents the 3 students we're treating as 1. So we're going to be treating this group as 13 people. And how many ways can we arrange 13 people around the table? Well, that's just going to be 13 minus 1 factorial. But we also need to consider all of these 3 students, and we can arrange them in a specific order as well. And how many ways can we arrange them? We can arrange them in 3 factorial ways. So this is just going to give us 12 factorial times 3 factorial, and that's going to give us 2874009600 ways.